Hi mates, so the previous video I've been demonstrating my binary logic simulator that I've written in pure JavaScript, which is inspired by Minecraft redstones and torches. So literally whatever you can do with Minecraft elements you can do here on this plain HTML table. And we've been learning how to make like AND, NAND, OR, NOR, XNOR, XOR gates the previous video as well. But the problem there was the performance. So just to give you a quick idea what do I mean by saying that, let's quickly draft a clock, so sort of a pulse generator. So I have 3 inverters, and if I connect these inverters with the wires like this and run this start simulation, then when it goes like, for instance, 1 second per delivering signal from one like part from the circuit to another, it works more or less nicely. If we double the speed, it definitely goes faster, but it's a little bit lagging. If we try to like altering the circuit while it's working, well, it also might get laggy, especially if we get many elements. But the problem is, the major problem, let's say we go to like 100 milliseconds delay per like game tick updates. It's not a game, but you know what I mean, like the board update ticks. It's also like it's not really 100%, it goes slower. But if we put the delay to 0, so literally this should be happening instant. You see, like it works just like as it was like somewhere around maybe 300s, maybe 200s, I'm not quite sure. If we, for instance, try to make our board like 10 by, well, let's make it 12 by 12 and reset. So this tiny board in here, and if we try to do exactly the same thing, so we just make this exact pulse generator. In this case, the speed would be like okay. So I just start it again, and now I go to 100, and now it's the real 100 milliseconds delay. And if we go to instant, you see like it's really goes like, well, it's not almost instant, but at very least this is the desired output. However, if we change the board size to like 80 squares width and 40 squares height, it gets extremely laggy. So in this video I'm going to introduce the performance update that I came up with in order to improve the performance and to fix this sort of an issue. So what I'm trying to do is to make the, let's call it animation speed. Well, actually it's not really the animation, but the matter of like the entire the circuitry updates there. So I've made a solution that actually allows you having that. So, but before we run it, I just want to give you an idea like where this huge delay is coming from. So by default, I was using, so the main loop is within the start routine. So here is the start routine, which enables the simulation. So ultimately what it does, it just uses the set interval loop, and it just renders the board and updates the state to make sure that all the electrical parts, like not the electrical but logical parts, that gets updated properly, so the inputs and outputs get switched accordingly. But render board here, so what it does, we go to our render board. So you see like every time we render in the board, it creates the entire whole new HTML table element, and it fills it with all the table data, like table rows and table data sets. So just to give you a bit more idea in this regards, just to demonstrate how this works, if we just go to the elements, and if I just start this, you see like it's getting updated. So if I just make it a little bit slower, so you see like it updates all of the time. So you see like it creates table every single time. So it literally like creates memory for like managing this DOM element within the browser. So it's Well, yeah, obviously it's really cold now here in Ukraine, and we also have electricity drop down, so it seems like a reasonable idea to make the CPU of my laptop working as hard as it can to make it heat, and eventually I can probably feel some warm after. But obviously, like, this is not the way to go if you're looking for performance. So here is the alternative way of how one can handle this this kind of scenario. So let me update this to stop. So ultimately, what happens within the render board? So let's try to understand like which parts are really like getting updated, which results in a different picture, literally in the animation, and which elements remain static. So the table itself, like the attributes of the table, are always static. And the background color for every square is always this one, gray. So literally the square elements like TRs and TDs, these tags, so these TD tags and these TR tags. So we just have a look at those in here. So like table, table body, table row. So every single one is like remains the same. And the only thing that is being changed, so for instance here I just put add the wire, so it just gets updated, and now it has the div with it inside, like literally only this div is something that has changed here, so like it just now has sort of a child element. So I thought, what if I just update these child elements without ever touching these entire render board thing, so I don't need to render the HTML table every single time. So here is the solution. So I've created this function called quick render. So ultimately what it does, it loops over all of the board squares available, and in case if it hits the off board square, which is used to make sure like when we are calculating the trace in the signal where the current is flowing, if it just hits the edge of the board, we don't really want it to go to like the upper or lower row. So that's the reason. So we don't want, so it's not visible, but like here, like left, up, right, and bottom, we have like this off-board squares. I've been demonstrating this earlier, well, in the video where we've been developing this particular application. So it just traverses all of the squares, and then it just gets the DOM element for a current given square. I call it cell here. So document get element by ID and the square as like the ID. So we are getting this access to the DOM element to this particular cell, and then in case if it's not empty, so if it is empty then just forget it, but if it's not empty then most likely it might get updated. So we just altering the internal HTML, this in HTML, and we're calling our render element square just like we did from the render board itself. So depending on what element we have on the board, on the internal board representation, which is an array as well, one-dimensional array, so accordingly we are returning either the wire, powered or not powered, the button inverter, and all this stuff. So that's ultimately how it works. So this saves significant amount of time and effort and processing power to achieve exactly the same result. So I will now demonstrate to you how this works. I just start the simulation without anything available here. You see like this table is not getting updated, so it stays there, it sits there, it's there forever, so it's not like flickering, like not being deleted and then appended again. So this is very important. This saves a whole ton of processing power, and probably, yeah, this still might be sort of relevant. So if I just have a look at the table, so only those rows, so just if we just draw our thing up in here, we do this on the large scale, so like in here, and if we just draft our tiny little generator, like pulse generator again, and add some wires. In this case I start and now go into 100 milliseconds, so it's actually already a bit faster, but when I go to instant, you see like it's almost exactly the same as it was there. Well, it's still a little bit laggy, but it's incomparably faster as opposed to what it was when we've been re-rendering the entire board. So hopefully this makes sense. That's it from my side, guys. See you later and cheers.